and talking about some of the sort of details behind it. So we have an all-new battery pack, and then something we're really proud of is the new carbon-sleeved rotors for the motor.
Elon Musk may have just created the one motor that every EV company feared, not because it's faster or lighter, but because it's nearly impossible to copy even after Tesla showed everyone exactly how it works. While competitors are still fighting over battery costs and charging times, Tesla solved something deeper. They solved the motor itself. So what exactly makes this technology unbeatable, and why can't the entire automotive industry replicate it? Inside every electric motor is a rotor, a spinning piece of metal that converts electrical energy into motion. The faster it spins, the more power you get. But there's a physical limit that every automaker has always had to respect. When a rotor spins too fast, centrifugal force tears the metal apart from the inside out. The copper expands outward under the stress, loses microscopic precision, and the magnetic forces that make the motor work start breaking down. Once the rotor loses balance, the motor vibrates, overheats, and fails catastrophically. It's not a gradual decline. It's a hard limit built into physics itself. For decades, every automaker accepted this as law. You could spin a rotor so fast and no faster. Engineers at Mercedes, BMW, Toyota, Porsche, all the great manufacturers learned to optimize motors within that ceiling. The faster the rotor spins, the more power the motor produces. But they all hit the same wall at the same place. The physics was fixed. The limitation was permanent, or so everyone believed. Then Tesla wrapped the rotor in carbon fiber. The idea is simple in theory. Carbon fiber is wrapped around the copper rotor under extreme tension, creating a compression band that holds the metal together even as centrifugal force pushes outward. It's the same principle that keeps a wooden barrel from bursting when filled with water. The bands hold the structure from the outside while pressure builds from within. This allows the rotor to spin beyond 20,000 revolutions per minute without deforming. At those speeds, the Model S Plaid accelerates from 0 to 60 miles per hour in 1.99 seconds. That's hypercar acceleration in a family sedan. That's performance that makes a $200,000 Porsche 911 Turbo feel slow by comparison. That's the kind of acceleration people only expect from specialty supercars built in limited numbers by engineers obsessing over every thousandth of a second. But the performance advantage is only the obvious benefit. The real breakthrough is what happens when you stack all the advantages together. A lighter rotor needs less energy to spin, which means the motor draws less current from the battery, which means longer range on the same battery pack. The cooling system doesn't have to work as hard because the motor doesn't generate as much waste heat, which means the air conditioning doesn't drain as much power. The motor runs cooler, which extends component life and reduces degradation over time. The rotor stays stable under extreme acceleration because the carbon sleeve prevents deformation, which means the motor maintains efficiency even at maximum power. Everything improves simultaneously. The gains aren't marginal percentages. They're double-digit improvements across multiple factors. Faster, more efficient, more durable, more stable all at once. This is why Tesla's motor isn't just a faster version of what competitors have built. It's a fundamentally superior machine that wins on every metric simultaneously. That combination is nearly impossible to match without matching every single advantage at once, and that's what makes it unbeatable. Then Tesla did something that should have ended their advantage immediately. They opened the patents. Every major automaker on the planet could read the design, understand the engineering, study every specification in detail. Ford could study it. General Motors could study it. Volkswagen, BMW, Mercedes, Toyota, Honda, Lucid, Rivian. Every company that builds electric vehicles could see exactly how Tesla built the motor. The patents were public. The blueprint was available. You'd think this means the technology would spread across the industry within a few years. Someone would build a competing version. Competition would force everyone to adapt. That's how technology usually works. That's how it worked with hybrid drivetrains when Toyota dominated for years before everyone else caught up. That's how it worked with battery chemistry when companies figured out the lithium-ion approach and the whole industry shifted toward it. That's how it worked with charging networks. Someone invents something, others study it, Engineers figure out how to replicate it, the industry standardizes, and the original advantage evaporates. Except that's not what happened with the carbon-sleeved rotor. When competitors actually try to replicate the motor, they hit a problem that patents don't protect. The design is one thing. The ability to manufacture it is something completely different. And that's where everything falls apart for everyone, except Tesla. Creating a carbon-sleeved rotor requires wrapping carbon fiber around a spinning metal rotor, while the rotor is under extreme tension. The wrapping can't be done by hand or by conventional machinery. The carbon has to be applied at exactly the right tension, within tolerances that are extraordinarily tight. The temperature has to be controlled to precise specifications while wrapping happens. The speed has to be perfect, not close, but exact. The angle has to match specifications. The pressure has to be consistent. Any deviation causes catastrophic failure. If the tension is too loose, the carbon peels off when the rotor reaches operating speed. If the tension is too tight, it cracks under stress. If the temperature fluctuates, the adhesive bond weakens. If the angle is wrong, the fiber doesn't compress the rotor evenly and you get imbalance. When that imbalance hits 20,000 revolutions per minute, the rotor destroys itself. When manufacturing tolerance is off by fractions of a millimeter, this is exactly what happens in practice. Tesla built a proprietary manufacturing system to solve this. Robots controlled by artificial intelligence wrap the carbon fiber with micrometer-level precision, meaning 1,000th of a millimeter accuracy. That level of precision is far beyond standard millimeter-level tolerances. The system monitors temperature, tension, speed, and angle simultaneously, while wrapping happens in real time. Laser sensors verify every single rotor after wrapping to ensure there's no deviation from specification. Every rotor is individually inspected before it's ever installed in a car. Think about what that means in practice. Every single rotor that comes out of the factory meets exact specifications. Not most of them. Not 99% of them. Every single one. When you're manufacturing millions of motors, that level of consistency is extraordinarily difficult to achieve. It requires artificial intelligence learning from millions of data points, adjusting in real time, catching deviations before they become problems. It requires sensors precise enough to detect flaws at the micrometer scale. It requires systems robust enough that they don't drift over time or degrade with wear. Tesla's engineers built this over years. They ran thousands of experiments. They failed hundreds of times. They learned what works and what doesn't. They trained their AI systems on millions of wrapping cycles until the machines could do it perfectly, consistently, at scale. This manufacturing system didn't exist before Tesla built it. No equipment supplier manufactures it. No robot company makes something this precise for this specific purpose. No company licenses the process. Tesla's automation division, formerly known as Groman Engineering, developed it from zero using machine learning and robotics that required years of research, testing, and refinement to get right. And that's where the real dominance lives. The design that everyone can see is one thing. The manufacturing capability that no one can replicate is something else entirely. It's not protected by patents, but because it took years to develop, and only Tesla has it. Competitors now face a choice that's actually no choice at all. They can copy the design and spend billions developing their own manufacturing system from scratch, which means years of research, hundreds of failed prototypes, process refinement, and testing before they can produce rotors good enough for production. Or they can try to license the technology from Tesla, which makes no sense for Tesla because licensing would eliminate the manufacturing advantage that makes Tesla unbeatable in the first place. The result is a trap. Competitors can look at the blueprint and understand every detail of how the motor works, but understanding how something works and being able to execute it at scale are separated by a chasm that billions of dollars cannot quickly cross. Knowledge without execution is worthless, and Tesla owns the execution. The global implications are massive, and they reveal exactly who wins the next decade of EV competition. In the premium segment, where buyers are willing to spend $70,000 to $120,000 on a car, Tesla has an unbreakable advantage. They offer hypercar acceleration in a family sedan at a price point that makes every competitor look frozen in time. China has BYD, which now outsells Tesla in total electric vehicles. BYD is efficient, massive, expanding globally, and formidable. They've mastered battery manufacturing and cost reduction, but BYD doesn't have carbon-sleeved rotor technology at scale. They're competing on price and battery capacity, not motor performance. When a buyer in China compares acceleration and efficiency, Tesla still wins. That's a different game, and it matters because premium buyers aren't shopping by price alone. Ford invested heavily in the Mustang Mach-E and the F-150 Lightning. These are good cars with solid engineering and real customers. Ford is spending billions on electrification, but they're building electric versions of traditional platforms. They don't have motor technology that matches Tesla's acceleration and efficiency simultaneously. When a buyer compares the acceleration of an electric Mustang to a Model S Plaid, the gap is obvious. The fastest Mustang Mach-E with the performance upgrade gets to 60 in 3.3 seconds. The Model S Plaid does it in 1.99 seconds. That's 1.3 seconds faster. That's not marginal. That's the difference between winning and losing. General Motors has the Ultium platform and the Cadillac Lyriq. GM is investing aggressively in electrification. They're building sophisticated platforms and aggressive timelines. But they're using conventional motor architecture. They don't have the performance advantage that carbon-sleeved rotors deliver. Their motors are optimized within the traditional ceiling. Tesla's motor broke through the ceiling entirely. Volkswagen developed the ID series with German engineering and reasonable range. They have charging networks and strong European market share, but they don't have motors that can match the Plaid's performance. Their acceleration is respectable for a family EV. Tesla's acceleration is hypercar territory. Volkswagen's best-performing ID.4 gets to 60 in about 4.8 seconds. Tesla is at 1.99 seconds. That's more than twice as fast. Lucid Motors built the Air with superior range on some models, more than 500 miles per charge, which is impressive engineering. The Lucid Air Sapphire can reach 60 miles per hour in 1.89 seconds on track, or 2.2 seconds in real-world conditions. That's genuinely quick, competitive with Tesla on raw acceleration. But that's only the premium Sapphire model at $250,000 plus. The standard Lucid Air models are slower, around 2.5 seconds. Meanwhile, Tesla delivers 1.99 seconds as standard on the Plaid. The Sapphire is close, but Tesla still wins, and it costs substantially less. Rivian is building electric trucks and SUVs with interesting design and loyal customers. Their R1T and R1S are purpose-built electric vehicles, not adaptations of traditional platforms. That's a smart strategy. With the latest quad-motor setup, the Rivian R1T and R1S accelerate to 60 in around 2.5 seconds. That's genuinely fast, competitive with the Plaid, but only with the top-spec quad-motor configuration costing over $100,000. Most Rivian models use the tri-motor setup at 2.9 seconds. Tesla delivers 1.99 seconds as a standard Plaid configuration at a lower price point. The performance gap isn't as wide as with other competitors, but Tesla still wins on efficiency and cost. In the premium segment, where buyers are willing to spend serious money and care about performance, Tesla owns the technology. Buyers notice the difference between a 0 to 60 time of 4 seconds and 1.99 seconds. They notice efficiency gains that translate to real range advantages and faster charging. They notice when a car feels like it's powered by the next generation instead of the current one. They feel it in their chest when they press the accelerator. And no competitor has the motor technology to match what Tesla built, which means no competitor has the strategy to compete in that segment for the next 5 to 10 years minimum. While competitors are trying to catch up in efficiency and range, Tesla is already in hyperspace. What makes this story even bigger is what comes next. Tesla is building an even more advanced version of this motor for the Roadster, scheduled to arrive in 2027. Higher RPM capability, even more power, even more efficiency. When the Roadster launches, it will prove that Tesla's advantage isn't just current, it's permanent and widening. But the implications extend far beyond cars. Tesla's engineers are already discussing applications in electric aviation, where this motor technology could power electric vertical takeoff aircraft. The same properties that make the motor perfect for cars, lightweight and powerful and efficient, would be perfect for aircraft that need to hover and accelerate without burning fuel. Imagine an industry where Tesla also controls the motor technology powering the future of flight. Industrial applications represent another frontier. Wind turbines, large-scale energy storage systems, any machinery that requires a high-efficiency, high-performance electric motor becomes a potential market for Tesla. What started as a breakthrough in automotive motors could become the foundation for Tesla's business in the entire energy revolution. Not just vehicles, the infrastructure of electrification across industries. This is why the motor matters so much, beyond just acceleration metrics. Tesla isn't just ahead in one product category. They're ahead in the fundamental technology that powers the future. And that future extends far beyond what competitors are even thinking about. The real question that emerges from all of this is what happens to the EV industry if one company controls the core performance technology for the next decade or longer. Traditional automakers are used to competing on features, design, price, brand heritage, and performance. They're used to technology advantages being temporary, overcome within a few years as the entire industry adopts new standards and catches up. That's the historical pattern. But carbon-sleeved rotor manufacturing isn't something the industry will standardize on quickly. The patent is open, but the manufacturing capability is closed. And manufacturing capability takes years to develop, billions of dollars to build, and expertise that only Tesla currently possesses. This means Tesla's dominance in the premium EV segment is likely permanent for the next 5 to 10 years minimum, possibly longer. Any competitor who wants to match Tesla's performance will have to develop their own manufacturing system from zero, which means years of research before they can even start production. By the time competitors develop equivalent technology, Tesla will have moved on to the next breakthrough. The Roadster will be in production. New applications in aviation and energy storage will be launching. The gap won't narrow, it will widen. This is what it looks like when one company doesn't just win a product battle, but wins the systems battle that makes winning products possible. They showed the world the blueprint while keeping the execution secret. And in doing so, they proved that in the modern economy, knowing the answer isn't the same as being able to execute it. Knowledge without execution is worthless, and Tesla owns the execution.